Hey guys, exciting lesson today. We're going to be looking at the basic structure of everything you can touch in the universe. That's kind of a big deal, right? And for something that's such a big deal, it actually boils down to a fairly easy to grasp concept, in that it's a lot like Legos. A lot like Legos. So imagine, say, water. With water, we've been talking about it as if there are water atoms, and these atoms are, well, the atoms that make up water. And we've said that we can predict the behavior of water. We can talk about why it's a solid, liquid, gas. We can talk about gas pressure in terms of these water atoms. Many, many things. It's been a useful model for us. The problem with it is that it is wrong. Very wrong. There is no such thing as a water atom. So we need to clarify our understanding of this a little bit. And the way to do it is to actually think of Legos. And basically the way it works is this. We are talking about, or we're going to be talking about today, things called substances. And a substance is basically something that cannot be physically separated into other parts. So let me give you an example of something that's not a substance. If I were to take salt and pepper and mix them in the same shaker, I could pour out salt and pepper on the counter, take a very fine pair of tweezers, and separate the salt from the pepper. It might take a while, it wouldn't be really fun, but you could do it. You could make a pile that's just salt and a pile that's just pepper. With substances, you can never do that. You can't separate out the individual parts of a substance. So you can think of a substance as being like a set of Legos glued together. If I had these super glued, let's say super glued really, really well, there's no way I could physically separate them. They wouldn't come apart. Now there are ways to separate them, even if they're super glued. If I go crazy on this thing, I could heat them up, melt them, hit it with a sledgehammer. There are ways to break it apart, but there are no easy, simple ways to break it apart. And that's sort of what a substance is it's something that cannot be broken apart by any easy physical means. You have to use what's called a chemical reaction to break it down. And just as with our Lego example, there are really two ways to think about this. I can think of the substance as being all of this big chunk, so this whole thing as a substance. So I can think of this as one big block, even though it's made of, you can see, I hope, try and get that zoomed in there, even though you can see it's made of 3 individual blocks. And we're going to start by looking at what we call these individual blocks. So I'm just going to put some examples of the individual blocks used to make matter on there. These are called elements. So things like hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, and we could go on for a long time because there are 108 different elements. So that is, if you think of the element as being like the smallest Lego piece possible, it's just one piece, you can never break that down into smaller pieces. Sorry, that's really hard to get that in the camera. You can never break that down into any smaller pieces that are still recognizable as Lego bits. That's what an element is. It's an atom, and it can be broken down into any smaller portion that's still usable in terms of an atom. So we have hydrogen, helium, lithium, beryllium, so on and so forth. All of these can combine to form other things, but you can't break these down into anything more simple. Now the element part of that can actually refer to the atom itself. So this would be like a hydrogen atom, a helium atom, so on and so forth. You can also say element and mean like a big chunk of all of one type of element, or atom, excuse me. So you may have noticed at the front of my classroom I've got this big nasty looking black thing sitting in a beaker. This is actually just carbon that's made from dehydrating sugar with an acid. So that big black mass that you see in there is really just a collection of carbon atoms. And so we would call that black mass an element because it's just made of one type of atom. That being said, you can say that the collection of one type of atom is called an element, and also that individual atom. So we could say that this is elemental carbon, this one atom here. Now we have ways of talking about elements that are pretty convenient, and I'm going to clear out everything here except for the hydrogen. Notice that name's kind of long, hydrogen, and there's a lot of letters to spell out there if you were going to write this. So when we talk about hydrogen, we just give it a symbol. So a capital H represents hydrogen. And remember, this is one of the building blocks from which we can build everything else. So that capital H is our symbol for hydrogen. And it doesn't matter where you go in the world, what nationality of scientists you talk to, everybody knows that a capital H stands for hydrogen. And every single element, all 108 of them, have their own symbols like this. And we can look at the symbol, say, for helium. And I'm going to type this in. Helium symbol is He. Notice now that this has 2 letters, and you can see a pattern here. When it was hydrogen, and forgive me, let me make a copy of this for us. When it was hydrogen, the symbol was just H. Helium, is He. The first letter is always capitalized, every time. The second letter, or if there's a third letter for some of the bigger atoms, that's never capitalized. So it's just the first letter that's capitalized. All subsequent letters are lowercase. And each one has its own symbol. For instance, if we want to swap this out for lithium, the symbol for lithium is a capital L, lowercase I. So that's our symbol for lithium. Capitalization is important. And this goes on through for all 108 have their symbol like this. And again, that's useful because scientists everywhere know that that's the case. So that is an element. It's one of the little building blocks, a Lego, that we can build everything else from. When we have things like water, this is what's known as a compound. So again, there are no such thing as water atoms. Water is a compound made from 1 oxygen atom and 2 hydrogen atoms stuck to it. And the way this works is that these atoms stick together in such a way that they act like one object. That is, they stick together. Forgive me, my PowerPoint Kung Fu failed me right there. I want to arrange them and group them. So once you have a water molecule, as the name of this thing, formed, it's these 3 atoms, and they're stuck together, and they act like one piece. So again, no such thing as a water atom. We're ignoring that now. And we know that what we used to think of as water atoms are really 3 elements. 2 hydrogen atoms and 1 oxygen, all stuck together in such a way that they act like one piece. So with our Lego example, if we take an oxygen and we take 2 hydrogens and we stick them together in such a way that they're not going to easily come apart, we now have the compound water. And notice that this acts just like any of the other elements did. You can think of this as being one big atom if it helps you. And for the purposes of our models, thinking about pressure, solids, liquids, gases, etc., that is a very helpful way to think of it. These compounds act like they're one big block of something. And together, elements and compounds are called substances. And we can look at other compounds rather than just water. I'm going to ungroup these now so where they act like different parts. But you may have heard of the gas carbon dioxide. Carbon dioxide is a compound, and it's a compound of carbon and 2 oxygens. And all of these get stuck together and thus act like they are one larger atom. So when I think about a group of carbon or carbon dioxide gas, a big bunch of it, what I'm really seeing is a bunch of these groups of carbon dioxide all floating around together. And these will never be separated physically. You can't reach in and grab an oxygen atom and pull it off the carbon atom. It doesn't work that way. And notice that if I did separate out these, they would go as groups. So I always end up with the same ratio of oxygen and carbon, which is what Dalton found with his law of definite proportions. Now, one thing that's kind of weird about these compounds is that the property of the compound has not much to do with the properties of the individual elements that make it. For instance, you probably know and love salt, the stuff that's really, really good on French fries, table salt. Table salt is made from two atoms, sodium atoms and chlorine atoms. Sodium and chlorine are both elements, and they are both very, very dangerous elements for humans. Sodium will spontaneously catch on fire and sometimes explode anytime it touches water. And it's just a metal. Like if you were to look at a large chunk of sodium atoms together, it's this gray, really soft, kind of shiny metal. And if it touches water, it catches on fire. Chlorine is a green gas, so if you get a bunch of chlorine atoms together, it's a green gas that's very, very poisonous. In fact, it was used as a weapon in World War I, because if you breathe in chlorine gas, it reacts with the water in your lungs and forms hydrochloric acid, which will then proceed to damage your lungs and cause you to basically drown in your own fluid. A horrible, horrible thing. So neither one of these atoms is, or either one of these elements is particularly pleasant. But if you put them together as a compound, you group them together so that they act like one substance, what you get is table salt, which you'll notice is this clear crystal compound that tastes very good and is very necessary for our bodies. We need salt in order to function. So the properties of a compound may not have anything to do with the properties of the individual elements. They're very, very different. So recapping, we have elements, there are 108 of them, they're the basic building blocks of all matter. And you have compounds, which you have two or more of these elements stuck together, acting as a group. So together, elements and compounds make what we call substances. And that's our first category that we're going to look at, substances, and then smaller categories within substances. You have elements made of just one type of atom, and compounds made of two or more atoms stuck together.